The International Space Station flies 400 kilometers above the Earth at a speed of 27,600 kilometers per hour, or 7.66 kilometers every second. That means for us on the surface of the planet, the ISS will travel from one horizon to the other in about 10 minutes, depending upon the pass. To track the ISS, automatic control of my directional antennas is highly desirable. While this could be done manually using the switches on the controller, the use of a computer and tracking software sure makes the job a lot easier. This video will explain the automatic tracking software, n9cha, to track the ISS during an ARIS contact. The components include the Yaesu G5400B rotors, my tripod and mast system, the rotor controller extension cables, the rotor controller, the computer interface, and my Dell laptop running the tracking program by Northern Lights Software Associates, n9cha for Windows. After the software launches, you can see the current view showing a map of the world, the current position of the ISS, the track the ISS is currently on, and additional data display screens used for automatic tracking. Let's look at a few configuration screens to become familiar with how the auto tracking is accomplished. First, it's important to know that I've already calibrated and configured the rotor controller interface. n9cha is configured to accommodate the rotor hardware on this screen, Antenna Rotor Setup. The rotor interface is selected along with its configuration. In order to accurately and automatically track the ISS, n9cha requires 4 updated parameters. 1. The satellite to be tracked, in this case, the International Space Station. 2. Our location on the globe. 3. The current time. And 4. The current set of Keplerian elements for the ISS. To track the ISS, it is selected from a list of amateur satellites on the Configuration for Current View tab. Now, we'll input the location data for Hidden Oaks Middle School in Scott County, Minnesota. Google Earth is a great source for finding the position data. Our location is called the Observer, and it can be set up by entering the location name, the degrees latitude, the minutes, and the seconds. We're north of the equator, so we'll leave north selected. We now enter the elevation in meters, and then the degrees longitude, the minutes, and the seconds. Since we're west of the prime meridian, we leave this as west. Clicking on Add to Observers List enters the location into the database. Hidden Oaks Middle School is now available when configuring the current view in the program. Next, in order to be sure the laptop clock is accurate and to obtain the most recent Keplerian elements, it's an easy process if the laptop is connected to the internet. There's a utility to check the current time and synchronize if necessary. To update the Keplerian elements, click on the Kep Elements menu, select Internet Update, and select Configure Download. Make sure the HTTP tab is selected. www .celestetrack.com will show in the remote URL window. The connection type will be LAN or cable modem. Now click on the download button. The last download window will show the current date and time. n9cha now has the latest set of ISS Keplerian elements, and the tracking tables in the software have been updated. Now, let's look at the data panels in more detail. The vertical window on the right shows the status of the ISS. During an ARIS contact, I pay particular attention to the AOS time, the time when the ISS will be in range, and the until time, or the number of minutes and seconds until the ISS is within range. Two additional windows are used during a contact. The antenna tracking control window showing the position of the ISS and the position of the rotors, and if the automatic position control is turned off or on. And the Doppler calculation window, which I use as reference to adjust the memory channels on the transceivers. It's important to know the astronauts aboard the ISS do not correct for the effects of Doppler, so we on Earth do that for both receive and transmit. During an ARIS contact, the effective Doppler will change from approximately +3 kHz to -3 kHz from our center operating frequency. Now that all of the components and software are configured, I want to show an example of a couple of ISS passes over my QTH. In February of 2019, ARIS and NASA organized a special event celebrating significant achievements made during the past half-century. 12 slow scan images were automatically sent using the ARIS radio equipment. Hams from around the world received and decoded these images using several methods ranging from a simple handheld radio, antenna, and cell phone app to automatic tracking Earth stations like mine. My home QTH Earth station uses similar components as my portable system. I set up a couple of cameras to record the ISS passes, one to show the Earth station, and another mounted to the end of my 2-meter cross-element beam, which was covered in ice and snow at the time. Prior to the beginning of the predicted pass, or AOS, acquisition of signal, the antennas are automatically positioned by n9cha. Once the ISS reaches AOS, the tracking software turns the data column light blue, indicating active tracking. The rotor motors are toggled on and off as necessary. There is no speed control. They are either on or off. You can see during this path, my Earth station has a little backlash. It's not enough to cause the signal to be affected due to the beam width of my antennas, but more than I would like. Another project, I suspect. Anyway, as the path continues, the ISS transmission is received. Slow scan television images were sent using the PD120 mode. It takes 2 minutes to decode the image. Depending on when the ISS began transmitting, I could receive nearly 3 images during any given orbit. Notice the data in the tracking column change constantly. The tracking window is updated with the current position of the ISS and my antenna. In the Doppler window, you can see the effect being calculated from a positive value as the ISS approaches, going to a negative value as it falls away from me. After the 2-minute transmission, I had a nice picture on the screen. This event proved to be an excellent way to test and practice the automatic tracking of the ISS. The operation of the transceiver and the adjustments necessary to correct for the effects of Doppler will be the subject for another video. Thanks for watching.